Today we are blending tech and nature to create something truly unique. I'm gonna show you how to use a 3D printer to create a birdhouse with a motion activated camera to capture the feathered visitors in action. Hi, my name is Martin and I do side projects. I began this project by sketching a rough concept of the birdhouse. My goal was to create something both functional and modern, incorporating dedicated compartments for the camera and a battery pack. The design includes a base with a small ledge where the birds can perch and feed on the seeds. The birds' food will be stored in a hopper that automatically refills the feeding area. The hopper also features a separate compartment to house the camera, ensuring it captures all the activity. Now, I'm not an artist, so please excuse my poor attempts of drawing a bird, but this is the best I can do and you get a rough idea. To complete the design, the birdhouse will have a detachable top section which includes a roof to cover the entire structure. I wanted the main body to be printable in a single piece, ensuring it would fit comfortably on my 3D printer's build plate. I sketched out the entire build with some rough dimensions before going into 3D modeling. The electronics, including the battery, will be neatly stored in a compartment beneath the house. Finally, I designed the parts to snap together seamlessly with magnets, ensuring they stay securely in place. With the concept finalized, it's time to grab a cup of tea and dive into 3D modeling. For my 3D CAD software, I use Fusion 360 from Autodesk. I would never be able to afford this software myself, but since I recently lost my job and I'm a student again now, I got a free student's license, so thank you Autodesk. I use Fusion 360 to model the birdhouse, starting by creating a new component for each part of the build. I begin with a sketch on the XY plane to define the dimensions of the base. From there, I extrude the sketch into a 3D body and create additional sketches on the body to model the walls of the base. Using the same process, I designed the hopper and a ledge where the birds can perch and feed. Next, I create the opening for the camera along with mounting brackets to hold it securely in place. I repeat this process for all the separate compartments, ultimately creating 8 individual components: the main bird feeder, a roof that will be attached to the lid, a housing for the camera and a base for the electronics. Additionally, I include a spacer that will be glued to the base of the house, ensuring it sits on top of the electronics base while overlapping to keep out rain. I also designed a simple mounting bracket that will be glued to the bottom of the electronics box and can be screwed onto a wooden pole. Once the design was ready, I exported it to my Slicer software. Here I adjusted the print settings, layer height, infill percentage and material type. For this project I used PLA, which is a biodegradable filament and perfect for outdoor use if coated properly. And now for the most satisfying part of this build, watching it come to life on the printer. I have a pretty old and slow printer, but can't rationalize buying a more modern one since it usually gets the job done just as well. Let's see how this whole YouTube thing goes. Maybe I can buy a new printer in the near future. Let's take a closer look at the camera I'm using for this project. It's an affordable home security camera I picked up on Amazon for around 20 euros. The camera comes mounted on a small stand with a ball mount, but it can easily be detached. Another key feature is its ability to save footage locally on a microSD card, which is perfect for situations where Wi-Fi isn't available. The camera records video at up to 2K resolution, which is more than sufficient for our needs. It also features motion and person detection, with the motion detection being particularly useful. It allows the camera to activate only when it detects movement from the bird. The camera includes decent night vision, making it capable of recording even in low light or nighttime conditions. On the side you'll find a reset button and a microSD card slot. It's powered via a barrel jack on the bottom and requires a 9V power input. This poses a slight challenge since I plan to power the camera using a USB power bank, which typically outputs only 5V. To solve this, I purchased an inexpensive power converter that connects to the USB port, converting the 5V input into 9V output and plugs directly into the camera. After testing, I found that with a fully charged power bank, the setup provides about 3 days of standby time, more than enough to capture a few birds stopping by our birdhouse. Let's check back on the printer. This was the largest part to print and took about 30 hours to finish, while the whole project took around 100 hours of printing time. With the first part done, it's time to get the print plate ready for the next print. With the parts printed, the next step was cleanup. For larger pieces, I typically use a brim to ensure better bed adhesion during long prints, so the first task was to remove it. The brims usually peel off easily, and I use the deburring tool to smooth out any sharp edges. Most of the parts were designed to print without supports, but for the main body I added supports due to a few large overhangs. Unfortunately, the supports didn't print as cleanly as I hoped and were challenging to remove. In hindsight, I think the main body would print just as well without supports, so I'd likely skip them next time. I used some tools and tried to get most of the support structures out, which worked well enough, and as we say here, we are not trying to build a church anyways. Finally, I assembled the parts that needed to be glued together with a generous amount of super glue. The mounting bracket goes on the bottom of the electronics base, the roof is glued to the lid, and the spacer goes on the bottom of the main body. With the parts cleaned up, it's time to move on to painting. I didn't do any sanding as the prints were already smooth enough for this project, and sanding PLA is usually cumbersome and doesn't yield nice results in my experience. Instead, I jumped straight into the painting process, starting with a base coat to ensure even coverage and good adhesion for the final color. I used spray paint for this project as it's quick, efficient and gives a clean, professional finish. The birdhouse needed a bold and vibrant color, so I chose this red and applied it in multiple light coats to build up the color without drips or uneven areas. Between each coat I allowed enough time for the paint to dry, ensuring a durable and even finish. This red paint I'm using might not just look bold to us, it could also stand out to the birds, similar to how flowers on berries catch their attention. However, brighter colors can also make the birdhouse more visible to predators, so it's a balance between attraction and safety. Fun fact, did you know that birds see color even better than we do? They have an extra type of color receptor in their eyes, allowing them to see even ultraviolet light. Let's hope this red gives the birdhouse a welcoming look for its future feathered visitors. picked up an 8 cm pole from a local hardware store, which I knew would be a good fit for the mounting bracket I designed in this build. To install the pole, I used a heavy steel rod to create a hole in the ground before placing the pole into position. This was relatively easy as the ground was soft enough to work with. I chose this particular spot for the birdhouse because it's within reach of my mom's Wi-Fi network and provides some natural coverage for the birds, offering them shelter while they are feeding. The base sits a little too loose on a pole, so I got these rubber foam sheets that I used to adjust the diameter of the bracket and cut to length with scissors. 2 layers work perfectly to adjust the size. Finally, I used 4 screws to secure the base to the pole. Next, I placed the fully charged power bank and the voltage converter into the base, threading the cable through the hole in the main body of the birdhouse. I then plugged in the motion activated camera, secured it into its dedicated housing and slid it into its mounting brackets. The final step was to install a cover for the hole in the base to complete the assembly. This setup keeps the camera separate from the bird food and relatively protected from water. For bird food, I chose a mix of sunflower seeds and crushed nuts. From my experience, birds seem to prefer sunflower seeds over most of the commercially available pre-mixed bird foods. And now it's time to reveal the final result. The results? Absolutely worth it. This little project combines creativity, technology and my love for nature. And the birds seem to approve too. I'm really happy with how the birdhouse turned out. It works just as I imagined. All the 3D printed parts are free for you to download and you'll find the link in the description box down below. I've also included links to the camera, the voltage converter and the battery I used, just in case you want to build one yourself. Thank you so much for watching. If you enjoyed the video, I'd be super happy if you gave it a thumbs up and subscribe to the channel. If you decide to build a birdhouse yourself, definitely leave a comment. I'd love to hear how it went. Also, let me know what kind of project I should tackle next. Stick around for a bit if you want to see what the camera already captured. Until next time, at Martin Does Side Projects.